Linear transformations. One of the things that we're going to talk about next is how do changes in our list affect things. For example, if we took all of those scores that we just had, Sophia's, Gannon's, and everybody else's, and we added 5 or something to everybody's score, what happens? That's what this is all about. So the A is some kind of added or subtracted value. It could be a positive or negative value. And the B is some kind of multiplication or division. For example, B could be 7. Or it could be 1/7, which would be the same as dividing by 7. And what happens with these kinds of transformations? So what I want you to do is I want you to take that data set, the 5, the 7, 8, 9, whatever, put that in list 1, and let's talk about that shortly. So after entering this in, let's do our stat calculations. Stat, calc, enter, enter. And we have some data. This is our one variable statistics. Kind of the big thing that comes out of these are our mean, our standard deviation, and what we call the 5-number summary. Min, Q1, median, Q3, and max. Those are probably the 7 most important pieces of data that we talk about in statistics from a list. Okay, so I'm going to go back and talk about that right now and write them down just to be able to compare data. So from our first list, we knew that our x bar, or our mean, was 13.72. We knew that our standard deviation, which we called Sx, that was 6.71. And if I was doing the 5-number summary, I would have 5, 8, 12, 20, and 25. So these were, again, my min, Q1, my median, my Q3, and my max. Now what I want to do is I want to see what happens when I add or subtract something to this list. That's what's called a linear transformation. That would be the same thing as me looking at this A value over here and seeing what happens when I add 3. So I'm going to try that next. I'm going to go to my list. I'm actually going to do list 2. So I go to my calculator, and I go stat, edit. I'm going to arrow over to list 2, and what I can do is I can say take second 1, which gives me list 1, and add 3 units to everything. That's if you highlight the upper part. Highlight list 2. Hit enter. Second L1, or second number 1, plus 3. And what you'll notice is everything in list 1 had 3 added to it. Okay? That's an easier way than redoing all of list 1, in my opinion. Now when I go to stat, calc, I have to be careful because if I don't do anything right now, it's automatically going to take care of list 1. I don't want to talk about list 1. I want to talk about list 2. So I go second, number 2, and hit enter. And now I have my information about list 2. I have my mean, my standard deviation, and my 5-number summary. So let's take a look and see what happened. When I look at this, what I notice is my new x bar is equal to 16.72. My new standard deviation is 6.71. What happened to the mean? It went up 3. So the mean is affected by a linear transformation. What about the standard deviation? Same exact thing. It is resilient or resistant to anything that happens with the information. That's important to note. My 5-number summary, if I was talking about it, is 8, 11, 15, 23, and 28. This is my 5 numbers for the summary. I'm not going to write down minimum, median, all that kind of stuff. What happened to those? They all went up by 3. So only the standard deviation is resilient or resistant. So on our next part here, we take list number 1, which was our original data, multiply by 4, just to see what happens with the multiplication rather than an addition. And what we notice from our original data points. So that was kind of the important thing. We're multiplying by 4. And when we talk about it, what we see is that our x bar is 54.9. Or 90, repeating. What happened to the original data points, or the original mean? Multiply by 4. Our standard deviation is now 26.838. Did it stay resilient?
No.
No. So when you multiply by something with a linear transformation, the standard deviation is affected. However, when you add, it is not, or subtract. Okay, that's important. Our 5-number summary, if we were writing them down, we would have 20, 32, 48, 80, and 100. And as we probably would have guessed, it is affected in the same manner that addition was. So every single 5-number summary point from the original blue has been multiplied by 4. In this last slide for today, what we notice is that multiplying each observation by a positive number multiplies both the measures of the center, which means the mean and the median, and the measures of the spread, which for us would be the standard deviation, and since we talked about the 5-number summary, the IQR, by that letter B, which in our case was the 4. And so that was the same as our part C, if you remember. And then adding a number A, either positive or negative, will add that A to the center and to the quartiles, meaning the minimum, Q1, median, Q3, all that kind of stuff, but does not change the measure of your spread like our standard deviation. So that was the same as our part B. A density curve is a curve that connects the tops of a histogram and tries to give a good description of the overall pattern of something. So for example, if I had a histogram that looked like this, then my curve might look something like the following. And you can kind of see, do you think this is symmetric? Do you think it's skewed? And it kind of just gives you an overall picture of what the graph is doing. So when we're dealing with density curves, which a lot of people will call the normal curve, there are 4 really important characteristics that you have to know. Like you got to know this stuff cold. Number 1, your density curves are always above the x-axis, never below. Number 2, the area always totals 1, no matter what. Number 3, it's going to describe the overall pattern. So we've talked about mean, we've talked about medians, we've talked about skewness, that kind of thing. Our socks. Right? So it's describing that. And last, the area between any 2 values is the proportion of observations in between those 2. So they use a few different words that I want you to know. Number 1, they use percentage. Number 2, they use proportion. And number 3, they use area. They all mean the same thing. Area, proportion, percentage. Okay, so I'd write those down if I were you. So area, percentage, and proportion all pretty much mean the same thing. The percentage will be written with the percent sign, proportion and area. Oh, there's one more. Probability, which we'll get into later. These four words are pretty much talking about the same thing with a density curve. All of these things are called density curves. Okay, last piece of information for today is how your mean is affected or how it affects something else. So when you look at the median, it's your place that divides the curve exactly in half. Okay, so median, think half. Whereas your mean, is the balancing point of your graph. So the mean, and it's a balancing point. The mean and the median are exactly in the same spot if the graph is symmetric. So this happens where they're in the same spot when your graph is symmetric. Whereas when you see the mean in a different spot, your mean is pulled in the direction of the skewness, or the skew. So you'll notice how your mean here is pulled to the right because your skew is to the right. So the middle graph with 50% of the data on either side is the median, but your mean, the balancing point, is always pulled in the direction of the skewness.